Welcome back, guys. This is Legit Lee back again with another video. So yes, that's right, I had 3 stream videos today. I was gonna just stop at doing the whole motor, the air motor, or air engine, but I wanted to show you guys this because I've been working on this a little bit too. I'm into cinematography, I guess. Like, I like making videos. Obviously I'm on YouTube, so that's the main reason, but I really like doing videos because of the fact that there's something I'm really into. So basically what I'm designing here in Blender is something I'm going to be building in real life. That's pretty much what I use Blender for, is design stuff and build it in real life. So even if I was just making a movie or something, I probably would make it all real dimensions and everything, but all I know is Blender is an awesome tool, and I wanted to show you guys what I was designing here. So here we have a few parts that you may already recognize. So this right here I got off of, well, pretty much all the design information I got off Thingiverse, but I extruded and fixed them to what I needed them to be. But this right here is actually a design made by a person on Thingiverse, and it's actually the A7 III from Sony, and that's the camera that I have. It's a mirrorless camera. It's great. Records in 8 bits. So that's not so great, but it does a really fantastic job, and it's light, and it's a mirrorless camera, so it probably weighs about 2-3 pounds, something like that. And this guy designed the camera and a lens for it. This kind of actually looks like an 85 or maybe a 35 millimeter. I can't really, he didn't specify, so I'm just using his design here. I imported it into Blender. It's the same as that A7 III. All the same button and functions and everything is on here. He designed it as a toy for kids, I guess. So it has the viewport window is actually completely see-through right here. But so this design is made with 20 by 40 aluminum excursions, and then this right here is a actual pillow block bearing for 8mm holes, 8mm diameter hole. And I got this off of Thingiverse too from another designer. And this is a real world item as well. This you can actually buy for like, I don't know, $4 to $5 on eBay, or I'm pretty sure Amazon as well. And basically these are actually for like when people make CNC machines, like those little small ones. You use a 8mm rod as kind of a generic thickness of a rod, so people use them for 3D printers and CNC machines. So I actually have a few of these, so that's why I'm using it. So in the future I'll be actually designing this from scratch, like how I'm designing it here, but in real life, and I will be drilling out the holes and everything. So I'm going to be using a 8mm rod, which I already have, and I already have this piece. So this will be connected with a thrust bearing right here that'll allow it to move freely. And same thing with the other side. And then at the top, if you can see it, we have some NEMA 23 stepper motors that will be connected with a bearing and, well, actually a pulley. My mistake, a pulley. Probably like a 16 or a 21 tooth. I don't know exactly yet, but I have 2. This will be just to move this. This is twice the torque. Now I could have added just one, and then added a pulley that gives a gear ratio to give more torque than force, or speed. But I decided if I'm pretty sure I have enough motors that I can use 2, but you guys can do 1 if you wanted to or something. But anyway, so it'll be connected with a pulley and a belt that can be connected here with another pulley, and then it will be able to move this up and down or left and right. So our pan and tilt, basically. So if you can see this, we can actually rotate it. So if I hit R to rotate, we'll be able to move it back and forth. So that will be what the camera can do. So you have that pan, you'll have that tilt right here. This is up and down, and will be tilt. And then up here would be our panning motion. So we would have an 8mm rod with a pulley attached to this motor with another pulley and a belt that allows it to turn left and right. So if we go, first let me go here, here. I'm gonna undo so I don't have that move. That's good. And then if I select this, and select all of these, there we go. If we go to the top here and I put move cursor and we just go towards the center, it's not going to be completely accurate, but right about there. And if I do set origin to cursor and then we go back to move, our origin will be pretty much at that cursor mark. It's not exactly there. Set origin to 3D cursor. It's okay. Anyway, so if I do that, and then we go to the top, and then we rotate, you can rotate left and right for our tilt. Now you can do this with bones. They have like, you know, rigging or whatever. You can do that. I haven't done it yet. I'm not done designing it yet, so I haven't got that far into getting everything set up. But obviously you guys can see that it looks pretty good. I already got a lot of leeway, a lot of head leeway done, I guess, or a lot done with this. All this stuff I actually already own. So I have the A7 III, I have the pillow block bearings, I have some aluminum excursions, but I'm probably gonna have to buy some more because these are super long. And I already have stepper motors. Matter of fact, I can count to see. You got 1, 2. Yeah, I should have all 3 of those. And then this right here I have as well. This is actually a plate for this piece right here. This is actually a plate that Creality sells, or you can buy for Creality style printers. It's the actual heated bed mount. So I bought one of these for that all-in-one 3-in-1 3D printer. So I actually took it off of there, and because I broke the whole machine down, I was making it into CNC, which you guys probably would have checked out at those last videos there. But so basically, I'm not using this roller bed, and it has some V-mount wheels that go into these slots right here that allows it to go left and right. So if we was to, let me just select all this. So if I hit B, select all these and this, all this, and say if we were wanting to glide over, so this would be like a slider, so like a camera slider, so go left and right like that. So it'll be able to, like, I'll have like an end stop so it won't hit right here, and then the same thing on this side so it won't hit right there. So it will go left and right the whole time, being able to move the whole entire thing. Now, only thing I have to do is actually design a part that allows it to go down, because I want it to be able to actually go like up and down through like with a lead screw. So it would be me just selecting these parts right here. Oh no, hold on. Me selecting these parts right here, and then being able to like extrude, like not extrude, but do a Z movement, so it'll be able to go down. So I mean, it'll probably be longer than this, that pole, but basically it'll be able to go down to where I can get some really cool, clean product shots. So say like that's an EMA 17, that's an EMA 23. So if we went like right here, for instance, and you know, or like just like this is in the way, but you know what I mean. If I was to do something like that, and then like, you know, this side it'll be like looking downward or something. Like I have a lot of room for play around here. So let's just say once I'm done designing it, it should be able to do a lot. These, I have the measurements as well for this size, but the good thing about this is it's super amazing because you can make it as big as you want, and it's so customizable because of the fact we're using aluminum excursions. So what's going to happen is with the aluminum excursions, say if you have a bigger camera, for instance, like I don't know, a Canon 1DX Mark II or something, right? Say you have one of those type of DSLR DSLR cameras, not a mirrorless. Well, you can make this longer by just getting a longer piece of extrusion, and then this part will have to be longer too. But you know what I'm trying to get at is that you can extend this out to fit whatever camera you want. I don't know if it'll be able to hold like a red camera or anything that has like a lot of weight, depending on what stepper motors you use and how much torque they have and what your electronics are and what kind of power you're running. There's so many things that come into play when it comes to this, but the frame itself is solid. Like this thing right here will be super good. So say we get these two pieces and we'll mount that. This will have to be connected here as well. I'll be using like angle brackets probably to mount everything, whatever the case may be. But that's what I'm trying to mention is that the longer the extrusion, the longer and more travel you'll have for your stuff. So you can scale this out to whatever you want and have as big of a camera rig as you'll need for anything. So, and it's super easy to break down. All you need really is if you buy regular like M4 or M5 screws that have like a Phillips head screw that you could use a screwdriver for, you can break it completely down, disassemble it, put it inside of your camera bag or something. You can literally make this work for your camera or something. You like how you would tilt around a regular slider or a regular tripod or anything like that. You'll be able to break all this down with just a flathead screwdriver or a Phillips screwdriver, whichever screwdriver you may have, and then be able to put it right back together again and be able to make it do everything you want it to do. So I wanted to show you guys this because this is going to be once I design this and make it, I'm going to be making my company. So my company is based off of 3D designs that I make, like how you guys see on my streams, and also camera gear. For the most part, it's going to be a lot of camera gear related items, and like I'm into anime too, so there's going to be a lot of anime based stuff. So if you guys are into any kind of Japanese or even regular cartoons like Rick and Morty and Final Space, stuff like that, I'm super into. I like those cartoons. So if you guys are into anything like that, all this stuff is going to start becoming available on my eBay page that I have. I am an eBay seller. I've sold a few things, but I haven't made like a complete store yet. But I do have an eBay store ready, and it's about to start having things being applied to it, so I can actually start making all these things. So you guys already seen some of my streams and seen the things that I've been designing, so you guys already know that everything I do is super legit. I'm fully about to dive into my whole company here. I'm not sure about the name just yet. I haven't fully got into the name of my company, but it is going to be a pretty decent one. And for sure by 2020, beginning of next year, which we only have a few months left, all this stuff should be already starting to be dropped. For sure, my follow focus system using stepper motors and stuff, because I already designed that, and this one I already have one already kind of made. I just have to start wiring up everything and getting it all set up so you guys can see what it can do and what it can't do and stuff like that. And this works out really good for mirrorless cameras because they're lighter. I mean, granted, the good thing about mirrorless cameras is they are light, but when you add lenses to them, they can get kind of heavy. So as long as the body's already light, you can add heavier lenses, which won't really bother it too much. It shouldn't strain your motors, depending on what electronics you're using. But what I like about mirrorless cameras is we can add pretty much any lens to this. So I have an A7 III and I have a Panasonic G7. Now I know it's a little older, but I mean it's super good. It records in 4K, has a flip out screen. It has the works, and it's a great starter for any beginner that isn't trying to spend too much. So this will be able to work for any one of those cameras, and you can mount different lenses to it. So right now, matter of fact, I have for my A7 III a Sony 28mm f2. That's a native lens, and then I have also a Canon 50mm f1.8, the Nifty 50, and then I have and that's the EF mount. The EF mount. And then I have a Canon FD 50mm f1.4. So that's an older style Canon lens that came out in like this, I don't know if it was 60s or 70s, maybe 80s, I don't know, around that era. So it's a really old vintage lens, but will be able to be controlled with this system here. So I have those two, and I have a few Canon FD lenses, and a few Sony lenses, and a few of the Canon FE mounts. So this will be able to control pretty much any lens because we're gonna have it being automated. So if we're gonna keep the lens on manual focus, and then we just attach a follow focus system, well, like a focus ring, and we're gonna be pulling focus and all that. So I'll be designing everything here in Blender first, and then we'll start seeing it come into reality here when I start buying all the parts. So since I have most of the stuff, I can really get it started. But the only bad thing is I don't really have any more aluminum excursions left at this thickness and size. So I'm going to have to get some more of those. That would be the only really price that I have to really pay for. But the design functions here, or at least not the functions, but the dimensions. We have 800 millimeter length excursions on the sides, so it can go from 0 to 800 from top to bottom with this. Well, not really, because we're blocking some of the travel with this right here, and plus you don't want to smack it on the ground. So I would say probably about 7. You have probably like a good 7. I don't know how low this is, so I can't for sure tell you that, but around 700 millimeters worth of travel. And if you think about it, that's in a complete box here. So we have 700 for the travel, and then let's see, then we have 1,000 millimeters from here to here to the ends. So we're probably cutting off about 80 because there's 40. So you have about 920 worth of space to be moved, depending on where I put the end stop set at. So 900 to 920, give or take, of travel speed from left to right. So up and down is about 7, 900 basically for left and right. And then for the pan and tilt, you have 160 degrees worth of travel. I forgot to tell you that. Let me just show you really quick here. So if we deselect everything and I just grab just these components, deselect this and this. Everything else, well, we don't need that selected, or this selected, or that selected, or this selected. Nope, nope. Okay. And I put that here because this is just a cube, but I put this cube here to measure out how far my what was it called? The God, I can't remember my microphone's, my shotgun mic's import. So on the left side here, you have a microphone port that you will plug in for your camera, right? So I measured out how far it comes out, so I wanted to make sure I had enough travel move for this to sit in. So if I ever need to put my camera, shotgun mic on top, then I can do that. The only bad thing about it is if you do put a shotgun mic, you won't be able to do 360 degree rotation. So what I mean by that is this is actually enough free travel move to actually spin all the way around without actually smacking anything up here. So if I do set origin to this dot right there, and we're going to set origin to 3D cursor, and then we hit this, what happens? Set origin to 3D cursor. I don't know why it's not doing it. Man, that upsets me. What's going on? Yeah, it should be the 3D cursor. I don't know why it's not doing it. Maybe if I rotate? See, now it's rotating odd. That's strange. I don't know why it's not working. If I go back to move, let's see. It's still doing it. I don't get that. It should be right here. I don't have nothing else selected, do it? I don't think so. So grab that, that, that. Yeah, we could just do those 3. Okay, yeah, now it's set to 3D cursor. Okay, good. I'm sorry about that, guys. I'm trying to make sure I figured out all this correctly. But yeah, so if we did a rotate, for instance, I'll do R to rotate. This would actually be able to swing all the way back. So let me just zoom here. So we got R to rotate, and you can see that it goes all the way around, and it won't actually touch anything. I mean, other than this, you know, this pole right here is in the way, but you know, I'm gonna fix that. That's not gonna be there, but you get what I'm trying to say. It can actually completely rotate all the way around. So the whole 360-degree rotation. And same thing with these up here. This will be able to rotate 360 degrees around, so we're good on all axes basically. There we go. So I want to put everything back to normal. So yeah, basically this is just a little side project that I've been doing for my company. I hope you guys are liking these videos. I'm doing a lot with Blender now, so I'm finally getting the hang of it. I mean, there's still stuff that I don't know yet, but I will definitely be researching as much as I possibly can on any free time that I have. But yeah, this design is going to be made fully where I can actually do, you know, Z travel for this to move up and down. Well, not that, but, you know, these right here would all be able to move up and down. So, these, okay. Not you. Not you. Not you. Why was it doing that? Stupid. Okay. Anyway, so yeah, this will be able to move soon. I'll have to design a part that allows it to do this. I'm not exactly sure how we're gonna get that set up, to be honest there with you. I'm still trying to figure out that part. But it definitely will be able to move all the way down, so I'm not too worried about it, to be honest with you. It should be easy for me to figure it out. But I hope, like I mentioned, you guys definitely subscribe. Let me know what you think, especially about my company that's coming up. You know, you guys are definitely going to be able to buy any of these things that I'm designing here, hopefully. At least most of them. Unless you're asking for something specific that I can design and make, I'll definitely can do that too. But yeah, guys, my name is Legit Lee, and I am signing out.